for example, let F be a field with 1 plus 1 equals to 0. Then we can conclude that x plus x equals to 0 for all x in the field. How do we do that? Okay, so proof. I'm losing my voice. Suppose 1 plus 1 equals to 0. I'm sorry guys if my voice cracked. I mean, I'm still sick a bit, so just bear with me. This will give us what? How can we get this? Okay? What we can do is we can multiply x on both sides. Again, has to be the same side, okay? So both I use the left side. This will give us x times 1 plus x times 1 equals to 0. Okay, so I used distribution law. And multiplicative identity, because I used this equal to 0. Okay, now from this you can get x plus x equals to 0. You used hold on, this is not multiplicative identity, sorry guys. And a times 0 is 0. Okay, we proved it before. We proved here. Okay, so we proved it here. I used what we proved. Here would be multiplicative identity. Okay, can't spell, so whatever. This is it. This is a proof. Next. Okay, finally we are here. The famous 1 plus 1 equal to 0 question. How do we prove it? I'm gonna divide this whole question into 3 steps. Okay? First of all, I'm gonna show a plus 1 equals to b. Alright, so let's show that. Suppose, let's use elimination. Suppose a plus 1 equals to a. Okay, this will give us, okay, let's just do the whole thing. Okay, this will give us 0 plus 1 equals to 0, which means 1 equals to 0. This is false, which means a plus 1 is not a. Now suppose a plus 1 equals to 1. Okay, this we do the same thing, but we add the negative of 1 instead. This will give us a plus 0 equals to 0. And this is a equals to 0. Another false statement, which means a plus 1 is not 1. I'm running out of space, so I'm gonna move this to the other side. The last one, suppose a plus 1 equals to 0. Okay? What we can do is we can write 1 as a times b, because we know that in 4-element field, a times b equals to 1. So let's write it as ab equals to 0. This will give us a times 1 plus b equals to 0. Okay? I'm gonna continue right here. This will give us, so let's multiply a inverse on both sides. This will give us 1 plus b equals to 0. 1 plus b equals to 0. Notice that we suppose a plus 1 equals to 0. Now we have b plus 1 equals to 0 as well. Okay, so this is not possible. This is a contradiction already. So here I prove that a plus 1 has to be b. Okay, therefore a plus 1 equals to b. Notice that I didn't specify any axioms I used, but when you do it, you should specify everything and do not skip any step, okay? The second step I'm gonna use is that I want to show 1 plus b equals to a. Here we don't need to do the elimination thing again, because we proved that a plus 1 equals to b already. So we can use it since a plus 1 equals to b. Okay, this will give us, so again, we're gonna write a times b equals to 1. So we're gonna write 1 equals to a times b. So this will give us plus, let's times b on both sides. B times a plus 1 equals to b times b. Okay, again, now we can use distribution law equals to b times b. Now we need to know what's b times b. Let's go back. B times b gives us a. So this is a. Now we have b plus 1. B. Okay, hold on. This will give us 1 plus b equals to a, because this is 1. Therefore, we have 1 plus b equals to a. Now, the last one, let's just prove 1 plus 1 equals to 0. This, since we know 1 plus a is b, 1 plus b is a, we can just use them. So right now, I'm just gonna write a plus b equals to, so we know this is true, which means we can write a as 1 plus b, 1 plus b, plus we can write b as a plus 1, 1 plus a, which will give us 1 plus 1 plus b plus a. Okay, just switch order. commutative. And you can use commutative again, so let's just switch them like this. Okay, probably and associative as well. Now you have a plus b equals to 1 plus 1 plus a plus b. So you can just add the negative of a plus b on both sides. You'll get this. Hold on, I have to add it to the other side. So a plus b plus the negative of a plus b. 1 plus 1 plus b plus the negative of a plus b. This side will give us 0. This side will give us 1 plus 1 plus 0, which gives us 0 equals to 1 plus 1. Okay? This is the final thing. Isn't this amazing? Okay, that is the end of the proof. Now we can go back and fill in the table. I'm just gonna cut this and copy it right here. Just make a copy of this as well, so I can summarize everything here. Okay, so this table and this table are for 4 elements filled. Let's fill that in. We know that 1 plus 1 is 0. Okay, 1 plus a is b. We showed 1 plus a is b, so we showed it right here. 1 plus b is a, 1 plus a is b, 1 plus b is a, and we showed that here if 1 plus 1 is 0, then x plus x equals to 0 for all x in f. So 1 plus 1 is 0, a plus a should be 0, b plus b should be 0 as well. And you just do Sudoku again. A plus b is 1, a plus b is 1. Okay? I'm gonna give you the table for 3 elements filled as well. So let's fill in the table. Zero, 1, a, 0, 1, a. Okay. The first thing, this should be easy because 0 times anything is still 0. Second line should be easy as well because it's a multiplicative identity. Okay. And the last one should be 1. Just play Sudoku again. Now addition. Addition is usually harder than multiplication. Still, this one is much easier than 4 elements. 0, 1, a. This should be easy for everyone. Now we have 1 plus 1. This should give us a. 1 plus 1 is a. 1 plus a is 0. 1 plus a is 0. A plus a is 1. Okay. This one, you might ask me, how did I fill this in? Well, you need to prove it, okay? So, this is really important. This sentence. Okay? Go home and make sure you know how to prove every single one of them. use elimination, use whatever we proved in lecture or in my video. Just make sure you know how to prove them. Finally, I left some simple exercises for you. Please do them for both 4 elements and 3 elements fields. Also, you can play with this. You can play with the table. You can make more questions yourself and test your friends. Let's see who can make more questions and do more questions. The solution to this will not be posted, but the file for the video I posted in the Google Drive I use for this semester. If you are not my student, I'll post the link in the comment section so you can check that as well. Anyway, this is the end of my video. I really don't have any voice left, so have a good night and good luck on your quiz.